Hello, everyone. My name is Clint Wyckoff, and welcome back to another episode of AWS Supports You. I'm an enterprise support manager based out of Pittsburgh, Pennsylvania. Here at AWS Supports You, we invite experts from AWS Support to come online and provide you with tips for optimizing performance in the cloud, lowering your costs, and sharing best practices and design considerations. AWS Supports You airs every Monday at 11 a.m. Pacific, 2 p.m. Eastern Standard Time. Be sure to block that time off. If you do happen to miss an episode of AWS Supports You, please head over to our YouTube channel. I'm going to throw a link here in a second to our playlist. This is where you can view all of our previous episodes that have aired. Today's topic for AWS Supports You is designing message patterns and cross-region delivery for Amazon SQS queues. And joining me today is Mike Wells and Aiden from AWS Enterprise Support. Mike, Aiden, welcome to the show. And let's start with a round of introductions.
Sure. Hey, I'm Mike Wells, a technical account manager out of Boulder, Colorado, and I enjoy supporting customers' operations, resiliency, and cost optimization efforts in the cloud. And today I'm going to give a demo of delivering SQS messages in multiple regions to be more resilient. But for now, I'll kick it over to Aiden.
Hey, I'm Aiden. I'm an enterprise support lead based in San Jose, and I'm interested in this topic because messaging is really foundational to addressing the reliability pillar of being well architected, right? And that's something TAMs do a lot of with their customers. So I'm happy to share more here.
Definitely, and obviously helping customers is a core capability or piece of what a TAM or a technical account manager within enterprise support does. So like we mentioned, today's topic is designing message patterns and cross-region delivery using Amazon SQS. Mike and Aiden do have a demo lined up, and if I'm not mistaken, there's even a pop quiz that they have planned later in the episode too, so you'll definitely want to stay tuned. But before we get into the details of today's episode, a quick note to the attendees online. Please feel free to use the chat option on the right-hand side of the screen. It'd be interesting to know where you're joining us from today. I'm from Pittsburgh, Mike's from Boulder, Aiden's from San Jose. Let us know where you're joining us from. And also, if you have any questions that you think of, please feel free to drop those in the chat. We'll be answering those live throughout the show. And we're definitely interested in hearing from you. So we'll throw a link to our survey. This gives you, the attendees online and the folks on the Twitch stream, the opportunity to share your feedback with us. Give us ideas for future episodes, and who knows, one of your ideas might be featured on a future episode of AWS Support You. But now that we've got the administrative items out of the way, Mike, can you give us a walkthrough of what we're going to be talking about today?
Yeah, absolutely. We're going to talk about some of the motivation of why we decided to talk about this topic today. And obviously the topic's going to be about SQS and queuing and designing different message patterns. We're going to talk about messaging versus streaming and how to differentiate the two and when to use what. We have a really cool decision tree to be able to go through and choose which different messaging service that you're going to use. It can be sort of confusing with a multitude of different services, which one is the best fit for you. We're going to go through some different patterns of how to design your messaging architecture. And then we're going to talk about the architecture of a cross-region delivery to SQS queues, and then we're going to go into a demo of that, and I'm going to show you how to build that. Aiden, you want to start us off and talk about some of the motivation?
Yeah, Mike, totally. So I love this quote. So, if your application is cloud native, large scale, or distributed and doesn't have a messaging component, that's probably a bug. And this quote comes from Tim Bray, the co-author of the XML spec, former colleague. And it really reminds me of our CTO, Werner Vogel's comment that, quote, that everything fails all the time, right? And failure is something to be dealt with every single day and to be architected, to architect out of. So, and address. So, that's our first motivation point here. What we're really talking about is decoupling tightly coupled systems here with using messaging. And just like a telephone, like a telephone call, right? This is from a fellow solutions architect in Germany, a messaging expert here. Dirk his example he brings up in reInvent talks and other places is like a telephone call. It's a very synchronous method of communication, or like a real-time chat. There are times and places for synchronous communications, right? But microservice or application communications have a number of really significant drawbacks that messaging systems can help with. So, like, for example, a problem in one downstream service can have immediate impacts within seconds on all of the upstream callers if you don't have a method to buffer and handle some of these errors. And you may already be using an SDK which has like retries, right? And immediately this can make the problem much worse. And you can start fanning out and amplifying the problems as well if upstream callers keep retrying and pounding the downstream endpoints, right? So exerting some like upstream back pressure and allowing some time to actually process a massive amount of messages can really help smooth through and smooth out really spiky patterns, call patterns. Mike.
Too much time to wait. Say for instance, a messaging client that you might have, or a chat client, and you want to be able to get messages back and forth really quickly. We just don't have time to be able to wait for a lot of different connections to be made and all these different things to be able to happen that might happen in a synchronous system. We just need to sort of fire and forget and get the message in the queue. So things that are asynchronous by nature are very well suited for this type of for queuing services. Oh, what is this? Aiden, is this something you put in?
Yeah, it is, Mike. What could this be?
Oh my gosh.
Yeah, it seems to be a pop quiz. Where did this come from? So, Mike, I want to know, what is AWS's first service?
Oh, geez. AWS's first service. I don't know. Maybe I need some help from the audience. Can anyone type in the chat what they think AWS's first service was?
Yeah, I just threw it out there in the chat. So for the attendees online, what is AWS's first service? So we have. Let's wait a couple of seconds for some answers to come in before we start reading them off.
I'm sure glad I had this lifeline.
Yeah, we've got a few from the Tech Guy 21, from DEC1 SLH, from Lazy Coder 3, from Bialt, Mookie Monkey, Jib Jab 006, or Sophia 007. We've got EC2, we've got S3.
Oh, I like that one.
Net_cloud_tech says S3 or EC2. I forget. We have a few SQS as well.
Oh my.
Okay. All right. I'm gonna have to go with S3. That sounds like the most likely thing.
Whoo boy. Well, Mike, that is a great guess, but it's actually Amazon SQS, Simple Queuing Service, and it feels weird saying that out loud. And there's some trivia there, right, Mike?
Yeah, actually, the SQS was the first service that AWS built. However, the first one that we released was AWS S3, and then with a fast follow with Amazon SQS. So there, if you said S3, you were pretty close to right. SQS was technically the way that the question was formed. What's AWS's first service? Technically SQS, first production service S3. So interesting question. Good one, Aiden. You almost got it there.
Before you move on there, I dropped a link to Jeff Barr's blog where he talks about the 12 years at Amazon.com, which mentions SQS there. So I dropped a link to that over in the chat.
Oh, cool. That's a great article. Yep.
Cool.
Fantastic. Well, I guess let's talk a little bit about messaging versus processing, or message processing versus stream processing. So this is an interesting distinction between these two different things. In message processing, an individual message is is a core entity where we apply some processing or compute. It could be a financial transaction or a command to control an IoT device. And the occurrence of a message typically varies. In stream processing, a stream of messages is the core entity, and only by looking at many messages together can we get the value of each individual message. And the stream of messages is also constant in most cases. So also kind of going a little bit deeper into this, some common characteristics for message processing are that you can configure how many unsuccessful attempts to process a message, and the message should be moved into a dead letter queue where you can process the message out of order. And typically a message will be deleted by the consumer after the message was successfully processed. And this means there's no need to track which message is already processed by the client. They just ask for the next one, which is typically the oldest message that the broker has. And some common characteristics for stream processing, there's no built-in dead letter queue. This is why you have to pay special attention to how you handle poison pill messages. And we'll get into what poison pill messages are in a couple of slides. And if your client's constantly failing to process the message or gets stuck at this point in a stream and can't move on, a common solution is to put these messages into an SQS queue and handle them out of order. In stream processing, each client maintains a pointer to a particular position in the stream. And after you've consumed a message, you don't delete the message. You simply move the pointer forward into each message in the stream. And that's why it's important to understand that each client has to maintain its own cursor in a durable way. And we recommend DynamoDB for that. Aiden, you want to talk about some different choices? I mentioned a decision tree to be able to go through, how to make a choice of which tool to use. You want to talk through this with us?
Yeah, totally. So when, very frequently, your friendly neighborhood TAM, solutions architect, professional services, will be helping customers actually decide how to architect their messaging integrations, right? And this is a typical decision tree that we work through. And for example, our first question might be like, is this use case an IoT use case? And IoT is like sufficiently specialized enough with device shadows and their own sets of MQTT protocols and X509 certificates, and just it's messaging, but it's really particular for like fleets of millions of devices. And so that'll be like our first question. Then we'll ask like, is this a new or existing workload, and do you want to like refactor or replatform, and like what are our timelines that we're dealing with? Are you really using, like, what are you coming from today? Is there appetite to refactor? Are you extremely integrated into like commercial software, like some, Apache ActiveMQ, right? Or like IBM MQ, for example, RabbitMQ. And this, we go through this decision tree. So, what is our retention period that we need here? Is it like over 365 days? Is something that, like, if we need streaming, can like Kinesis data streams, KDS solve for us? So here we go throughout this, but really the point I wanted to make here is for a cloud native architecture and the most resilient serverless, least amount of management you can have. We really want to get to the bottom here, which is utilizing like Amazon SQS and SNS, Simple Notification Service, and that's really the happiest place to be to take a lot of benefits from the cloud. And even though it's one of our first service, right, it's still beautifully and very elegantly servicing millions of customers, right? And even like Amazon.com relies on SQS, for example, for millions of orders. And so this is really kind of a decision tree we go through. And we'll jump into some of these details, like what we mean by publish, subscribe, pub sub, and like point to point in a couple seconds here. But yeah, that's this decision tree in a nutshell. And TAMs help architect messaging infrastructure, just like with similar decision trees like this.
we move on, I wanted to check in to see if there's any questions from the audience. Questions, comments, concerns, hotspots, cold spots, numbness, tingling.
Yeah, we did have one question come along from the tech guy here that we'll get to in a second, but I did want to call out, like earlier on the previous slide you guys had up there, if you want to just go back one for me.
Sure.
The building block, which really unlocks a lot of different capabilities, is SQS, SNS, and Lambda paired together to build sort of like an event-driven architecture. We hear a lot of the reInvent talks and a lot of the SAs and the TAMs having conversations with customers around like an event-driven architecture. Looking at this slide, like where would EventBridge or where would Lambda sort of fill the gap here?
Aiden, you want to take that one?
Yeah, sure. So when we are similar to like a messaging bus or whatnot, like having the ability to funnel these events, like for example an S3 event. You've written a new you've created a new object in S3, how to actually fire that message off to the queue, which is the topic of our talk today. And then finally to some form of compute, like what do you want to do with this message? Do you want to, how do you want to process this message that's in there? What work do you want to be done on that message? And then lastly, to take it a step further, that would be in like Lambda, you'd want to write this message to like a DynamoDB table, right? That is the best place, arguably the closest fit to these messaging, but it could be like an RDS database, some form of maintaining that state throughout. So, but yeah, you're right. Event-driven architecture, really hot topic. It is one way to kind of encompass what we're doing here with these messages, right?
Right.
Event comes in.
So you have something that gets written to the event bus, whether the queue, it triggers an event that then might run some Lambda to do some sort of processing and then dump something output to a database, for example, or send it to another downstream system for further processing. We do have a question here from JibJab. How many subscribers can an SNS topic have?
Yeah, I'll take that one. An SNS topic can have up to 12.5 million subscribers, and that gives a high scale that can provide a highly scalable fan out. Targets can include HTTP, HTTPS, SMS text messaging, SNS, email, as we'll see today, SQS, and Lambda functions. Thanks.
Perfect. And then just to wrap up the question break here, unless any other ones come along, I'm going to toss this one to you. So what serverless Lambda pattern would you recommend if my use case needs a Lambda to receive a REST request from a client, and then it calls multiple other Lambda functions and collects the responses and sends it back to a client?
Yeah, this is sounding like a fan-out architecture which we'll cover as one of the patterns today, where you can have from one Lambda you can be calling tens or many other Lambda functions downstream, and it's done with a combination of an SNS topic to multiple different SQS queues and to multiple if you wanted hundreds or thousands of Lambda functions to fan out. And before Lambda, this was done with like EC2 auto scaling hooks, right? How deep is the queue length to the number of EC2 instances, right? So yeah, I'd say a fan out is the ideal topic there. Yeah.
Perfect. I don't see any other questions in the chat for now. So folks, if you do come up with anything else along the way, please feel free to add those to the chat. But for now, Mike Aiden, back over to you.
Yeah, so next up, we wanted to talk about some different messaging patterns. And Aiden recommended this book, Greg, that called Enterprise Integration Patterns. And this QR code will take you to a link on Amazon to be able to get to the book. But also, I think, Clint, if you don't mind putting in the link to the book, then we should have that in the chat as well. Aiden, you want to kick us off talking about some different patterns for messaging?
Totally, yes. And by all means, by no means, like That book has over like 65 different messaging patterns, and if you really want to dive deep and explore like what your performance trade-offs and different use cases might, what your specific use case might be, that is a great source to actually see way more. I think we're covering like 10 patterns today, but 65-ish patterns there and more. So check that link out for that canonical source. Yeah. So yeah, first and foremost, let's talk about like message exchange. Like on the left here, with a one-way fire and forget, workflow here, we're not expecting a response. You may not expect a response, right? You'll see the semantics. You have a sender sending message A to a receiver, right? And this is like a perfect way of explaining tons of different workflows with not expecting, where you don't need a response back to the sender. So, and by the way, we're keeping this a little bit, we're not putting labels immediately on SQS or SNS, as some of these topics can apply to like ActiveMQ and other different queuing and other different messaging platforms, right? The other major message exchange is like a request response, where you need a response back to your requester. And so the responder here formulates a response B and sends this back through a second messaging destination. So that could be another queue, for example, back to B. So you have to know the return address of who sent it, and you'll have to correlate this. So this means there's some extra processing, but there's a lot of workflows where you need to know you're actually waiting back for a return message, like what is the quote, the mortgage rate quote that I actually want to know. That's why I asked. So, so yeah, just high level, you can have fire and forgets, or you can have request response messaging patterns here from the get-go. Next, let's jump to the next slide. Yeah, perfect. So let's get to what we're used to hearing about, right? Which is queues and topics, really. So from point to point, so using a queue, like an SQS queue, it's like a buffer, basically. You can put messages into a queue, and you can retrieve messages from the queue. And this sounds extremely straightforward, right? But the queue operates, so it's only consumed by one receiver. Although you can have like multiple receivers connected to a queue, and actually for simplicity, there's one sender here, but you could have multiple senders as well. In this case, we have 3 receivers for messages A, B, and C, making it really easy to scale and really helps to flatten out peak loads, right, for your really spiky workloads. And this is what I mentioned, the like upstream back pressure, because if your sender is producing way more than your receivers can process, you don't want to overload your receivers, right? Each request could run up a lot of compute, and maybe you don't want to auto scale infinitely to for your own reasons, or you're not auto scaling at all even. A queue is really helpful to flatten out those peak loads. And just some semantics, you'll see that there's a queue on the left, right, a sender and a receiver, while on the right, when we're discussing topics, notice it's a publisher and a subscriber. So to discuss, the pub sub topics, right, like a topic, like an SNS topic, is like a broadcasting station, right? You can publish a message to a topic, and anyone interested in receiving these messages can subscribe to the topic. And in this model, it's immediately received by all the subscribers in the topic, unless you've applied some filtering pattern, right? Some extra grouping that we'll talk about in a couple slides. And there's another concept with topics, which is durable subscribers, so actually maintaining that topic for some short amount of time. This we see more with like Amazon MQ or ActiveMQ, where they can keep that, in case the subscriber is offline, right? Like you send a text message, the person's phone might be off, the machine, and you have that for a short amount of time. So that's kind of merging a queuing and topics a little bit, but you see some durable subscriber semantics for like, ActiveMQ, Apache ActiveMQ. So that's the foundation, really, of our messaging patterns here. And now we can get into some of the more interesting topics. So Mike, take us to the next level here, please.
Yeah, let's talk about topic queue chaining. This is kind of, if you, where we see most common this pattern being used is in web application building. And if you need to scale receivers per receiving application, this is going to be the best way to do it. There's two other patterns that you can build off of this, which is scatter and gather, where you fan like this, and then you fan into an aggregator, with a use case being like requesting mortgage rates from 3 different vendors and then selecting the lowest rate. So it's really fanning out. We're going to talk about this in the demo as well, how this topic queue chaining goes out. This just lets you be able to send out this message directly to a topic, and then each one of these different queues can be subscribed to the topic and then send the message out, and then each one of the different receivers can receive different messages out of the queue based on their processing capability and which types of things they're supposed to be processing. Another one that we have is the dead letter queue. And a dead letter queue is a queue, like if you send a message to a queue and then a particular message is not able to be processed for whatever reason, maybe it's ill-formatted, maybe it's just something that's outside the bounds of your application, messages get sent to a dead letter queue whenever they can't be processed. So this handles transient failure mitigation. It also is very useful for debugging your application or messaging system, because these dead letter queues let you isolate unconsumed messages to determine why the processing doesn't succeed. So you can have some other system processing this dead letter queue to be able to go through and say, oh, we're getting a bunch of messages that come in that have, some weird header or some weird attribute that's not able to be processed by our receivers. So that's the dead letter queue. Aiden, you want to talk about FIFO?
Yeah, totally. And also just for dead letter queue, poison pill handling was the other.
Oh yes. Oh shoot, I forgot that. Yeah, go ahead.
No worries. The other point of, it's nothing malicious. It's just sometimes even your end-to-end testing can't find, isn't able to process a message. So it, instead of performing like open heart surgery and SSHing into a number of hosts to figure out what's going on, it can sit in this dead letter queue for processing and debugging. Cool. So let me jump into a couple more important patterns here. So first in, first out processing, right? When you have a use case that really needs strict ordering of messages, you can use, like, for example, SQS has a FIFO queue offering as opposed to just a standard queue offering, which tries to deliver an order. But if you really need to guarantee that order, you can use the FIFO queues, and that's what we're seeing here. There's some scalability considerations for FIFO queues. By default, it's a lower TPS, transactions per second, but you can get it, like 300 TPS, I think defaults to, you can get it up to like 3000 TPS if you batch, 10 requests, 10 messages per request, so like 3000 TPS. There's also another feature called message grouping, where, as you can see, message A, B, C, D, the orange messages, you can group those and filter those to different types of receivers to handle those as well. And those can be processed by different sets of consumers, right, from different sets of receivers. So these are two extra concepts to be aware of. Yeah, that's that's FIFO, first in, first out, and message groups. So jumping over to quality of service, QoS, and there's other semantics that do come up when discussing messaging topics. And at least we hear, at least once. I need the message at least once. That's what we're referring to, like Amazon SQS standard queues. That means there can be a duplicate. That's what that really means. And when you say at most once, we're talking about the semantics of Amazon SNS FIFO queue, and probably the most stringent one here really is exactly once, and that's what can be guaranteed with SQS FIFO. So these topics do come up, and they are tunable. That's the good news. So you don't have to build everything in your client side and your receiver side to handle this. You can lean on some of the FIFO capabilities of SQS and SNS, especially if you're doing a fan out like a lot of customers are doing. Next slide here. So, we do discuss these topics quite a bit in meetings, and it's okay to push back when and really dig in and find out why do we need exactly once delivery? Do we really need exactly once delivery? Because we do have a lot of different tunable parameters we can deal with here. We can actually help with the deduplication by using the FIFO capabilities, right? There's deduplication IDs added here. There's group IDs added, and you're able to process this without introducing errors or duplicates for your customers that might confuse them, right? The other major, point here to make is, how do you process failures, right? This is one of the themes of this talk. And if you are designing your messages to be idempotent, where you send one message that you will have the same type of output from, that is the gold standard if you can here. And that helps with a number of different failure scenarios as well that we'll see. And jump to the next slide here, please, where you have two new concepts here. You have, for example, in-flight messages. When your C for consumer here begins processing that message, and they receive that message, and that makes it invisible for the rest of the consumers. But if that consumer is not able to, it's invisible for the rest of consumers. If they're unable to finish processing that message in time, then it's returned to the queue to be taken up by the next consumer to receive that message. And, and we jump to our next timeline of the visibility timeout. So here, if we successfully, in the case of SQS, we successfully do process that message, as the success acknowledgement there is to delete that message from the queue. And typically, if you could see like an instance goes down, for example, that's a common failure scenario. Or if you had a scale down event, you weren't able to process that message in time, then actually returning that message and not deleting it yet is the important part here. So yeah, that's a couple failure scenarios in a nutshell. Being idempotent is very important. Understanding when and where to use to build first in, first out, or use first in, first out queues. And yeah, I think it's time to discuss some architecture and see some code and see some of this in action.
That's great, Aiden. So what I did for our demo is I wanted to talk about cross or multi-region delivery of messages to an SQS queue. SQS queues are, SQS is a regional service. So whenever you spin up an SQS queue, it goes to a particular region, US East, US West, and each of these different, whenever you send a message to a queue, it just goes to the queue in that region. Well, for resiliency, many customers would like to be able to have a queue propagate into multiple regions in case of regional failure or any other type of problem, some type of network issue between producers and the SQS queue. So today we're going to talk about an architecture to fan out from SNS to multiple SQS queues. And as we see in this architecture, what happens, this thing on the left is just, I used a Lambda function for publishing to be able to publish messages into this, into these topics. So I'm publishing into, from the Lambda function, I'll publish into 2 SNS topics. And then each of these SNS topics also publishes into each of the SQS queues. So say, for instance, there was a issue here between this publish function and US East 1, then messages would still be published through this SNS in US West 1, and then subsequently the SQS queues would be filled with this SNS. So let me jump into it. Let me get the demo pulled up here. All right, sign in here. And what we're going to do first is build an SQS queue in the US East region. And this will be our primary queue. So we're going to jump in here. And you'll see creating a queue is pretty simple. So this is the earlier one I built for the demo. Let me create a new one here for this. And I'll go ahead and call it Amazon supports you in primary. It's good to name it primary so you can know which one we're doing. I'm going to choose a FIFO queue. Whenever you choose a FIFO queue, you have to add FIFO at the end of the queue name. So that way everyone knows where it's going to be. And I'll just choose the defaults for the rest of this queue. All right, so we have a queue ready to go, just that simple. So let me build in this region an SNS topic to front this queue with. All right. And again, I'll create a FIFO here. And we're just building an SNS queue to go in front of the SQS queue that we've already built. And both of these are built in the North Virginia region. And now we have, I'm going to go and subscribe this SQS queue to the SNS topic. So each time a message comes into the SNS topic, then it's broadcast out to the SQS queue, and then we'll have messages from whenever it comes from SNS into this SQS queue. There we go. Simple as that. And now let's jump over to, I'm going to start a new tab here so we can keep this one open for later, but I'm going to jump into a new tab to create a new, jump over to our other region in US West. 1 will be our secondary region where we fail over to. So I'll go ahead and create an SQS queue here in the US West region. Or let's create an SNS first. We'll create the SNS topic in this region. And we're just building this secondary SNS topic to be able to have this duplicated in another region. So whenever we need to fail over, we'll have an endpoint to be able to reach out to put messages into these queues. And I'm going to build an SQS queue in this region. This will be our secondary SQS queue. So whenever we decide to fail over, our consumers can consume from this SQS queue. And again, I'll just take the defaults here. And now I'm going to subscribe this to both SNS topics. So whenever messages come into either SNS topic, then messages are delivered to this queue. And I'm going to add it to the primary. And now I'm going to subscribe the, from the primary region, I'm going to subscribe this to the secondary SNS topic. All right, now we have our architecture set up. This is the same architecture that we had that I showed on the screen that shows that has two SNS and they're delivered to two different SQS. And let me jump into Lambda here to show you the code for actually publishing to these queues. Let's see, I have a publish message function, and this is in the North Virginia region. It can be anywhere. I mean, these publishers can come, I mean, these could come from local also. And here is the code. I went ahead and wrote this because I didn't figure everyone would want to sit around and watch me write code here. So what this code does is it attempts to contact the primary region first. And then if there's any type of error, and there could be a multitude of different types of errors, and I'm just running this in a try catch. So, or Python. And this, I started out my career in Java, so I always think try catch, but this is Python code, so it's try accept. And so there are a multitude of different errors that could happen from this producer to be able to go over into the, to fail over to the secondary region. Those issues could be network, it could be a region down, and for brevity in this code, I'm just doing try and accept. And in this case, whenever we catch a client error, we might want to publish something to a DynamoDB table to let our producer or let our consumers of these messages know that they also need to fail over to another region. There could be other steps that you need to take to know what needs to happen whenever you fail over to this region, just depending on, it's application dependent. So it's a lot different if you're handling chat messages that could potentially be repeated, or credit card messages, which definitely do not need to be repeated. So there is, in your application logic, you're going to have to handle some of this failure code. But in this Lambda function, whenever this exception happens, would be a good time to be able to fail over. And what I'm doing in this code is just sending in the ARN for the SNS topic that I'm going to be connecting to in the region, and then having a secondary to be able to fall over to in this test function. So we'll continue forward here and look at some more stuff with this code. Let's see. Yeah, and in this thing, I'm also importing the UUID. And I'm using that for content deduplication. We also have like contextual content-based deduplication, where we can use the service itself to be able to deduplicate messages whenever they come in based on the content. So it builds a SHA of the data, SHA 256, I believe, and then keeps messages from being repeated. Which is an important step here. So let me continue on from here. And yeah, this is the so this is the actual context that I'm sending in. As you can see, I'm just sending in the ARN of the SNS topic in the region to be able to fail over to. So let's test this thing out. Let's see it actually work. So I'm going to copy since I built this demo before with these other queues, I'm just going to go and grab the ARN from these SNS topics that I'd already created, or I created on this demo. I want to show you exactly what we're doing here. So I'll copy this ARN in. Let me grab the ARN from the other SNS queue, US West. And all right, let's send a message and see what happens. So now we just sent the message, and it's going through the primary queue. So it's sent to it should send to the primary SNS topic and then land in both queues, just in case something happens. We'll have the message in both SQS queues in US West and in US East. And there we go. There's the message in US West. And let's go check US East and be sure our message landed. And there it is. All right. And that is how you build multi-region SQS to be able to send messages out, to fan out to 2 different SQS queues. Yeah. And again, this is just the architecture that we had to be able to fan these guys out. So 2 SNS topics in front and 2 SQS topics in the back. Yeah. Aiden?
We could that Lambda that you're publishing from could be anywhere. It could be
totally
like an outpost rack in your closet or data center or your laptop or whatnot. So you could be sending these messages to other regions, to both regions, 3 regions if you want as well.
Totally. And whenever I initially built this, I was building it on my laptop on just running Python here. So I actually did have I had something happen where it couldn't connect to the primary and then failed over to the secondary. So it was a lot easier to demo from my computer in that way. That's sort of failure scenarios. But at any rate, that's how we have it.
So while you were giving the demo there and good stuff, and by the way, Mike, I'm sure every one of us would love to sit on a live Twitch stream and watch you write JavaScript.
Right.
We all might learn something new there. So the chat's been super busy, and I really appreciate everyone's interaction here. So the tech guy brought up an interesting topic here about scaling provisioned concurrency within Lambda based on SQS queue depth, right? And Aiden, you gave me a blog post that I tossed over in the link there, or over in the chat there, but I did want to just quickly talk about this topic. So how would that architecture look? So you have a message that gets dumped to a queue, and then I want to trigger Lambda off of that. Would that be an event bridge configuration, or what? Sort of walk through that?
Yeah, there's a few ways to do this from memory. The first tidbit I think would be to use like long polling from your SQS, so you don't rack up. Short polling is how you originally exactly you would incur extra charges there. You want, at this case, I think 20 seconds for long polling is going to work well. If there's no messages, it won't. It'll wait till the end of that long poll period, 20 seconds. And one Lambda function can scale, can request, can initiate, be the trigger for the extra Lambda functions that you have here. So you could go through Event Bridge as well. The Event Bridge, I think the previous name was CloudWatch Events, which was like our cloud cron, if you will. So that's another option if you're doing very heavily event-driven design. If you have other things you want to do, like you want to kick off like an AWS batch job, or you want to have multiple different use cases behind that. So just to sum up, like long polling, great start. At least one Lambda function will be having to call the extra Lambda functions. And another tip here would be to, if you can batch, take advantage of the 10 messages per each message that you can have with SQS. That's one cost optimization thing. I know we're talking resiliency mostly, but try and batch if you can as well. Like if you already know you need 10 or you need 100 Lambda functions to fan out, you can put that message in from the get-go.
Awesome. And earlier you were talking about the dead letter queue. It's funny. I was having a conversation with a friend who works for a company that has some legacy processing, and they had an overnight batch run that generates a bunch of emails that go out to their customers and stuff. And there was an extra period in the email address, so it failed. The entire processing failed halfway through, and we were just chatting about this like after work hours and stuff. And it's a problem that they came across. And I was like, oh, if you had a dead letter queue, you could process that. So, and these are common challenges that customers do have. And it's interesting to see how like the cloud can help optimize some of those different things and make it better,
Absolutely.
Yep.
Cool. So we talked about a lot today. You gave us a great demo, Mike, and I'm not seeing any other questions, some comments and feedback here. Alex Masha says, great session, guys. Earlier in the conversation, there was also some positive feedback. Indeed, very popular. So yeah, good stuff, guys. Very good conversation. Really appreciate it. Thanks for joining us. So today, like we talked about, we discussed messaging products from AWS here, specifically SQS. We discussed some different design patterns for those products. And then we also saw a demo of how to build a global receiver for SQS queues. If there are any additional questions, which I'm not seeing any over here in the chat, I encourage you to head over to repost.aws. It's essentially like an AWS online forum where experts like myself, Aiden, and Mike are sitting waiting to answer your questions. So you can look up the tag there for SQS and you can ask your question. And then that's actually a good place that we use seed topics for future episodes of AWS Support You. So please feel free to throw your questions there. Also, you can email us at the show, awssupportsyou@amazon.com. Definitely want to hear your feedback on what you thought about today's session, future topics as well. Next Monday is a U.S. holiday called Labor Day. So we're going to be taking off next Monday. There's not going to be any show. So we will circle back with y'all on September 12th. Whenever we're going to be discussing using Amazon Route 53 Application Recovery Controller. Very good topic. Mike, Aiden, closing comments before we call it a day here?
Thanks so much for joining us. It's a pleasure to be able to talk to you all about this.
Likewise. Thanks so much.
Fantastic. Yeah. And it's always a pleasure, gentlemen, to have you on the show. And for the folks on the stream, thanks for tuning in and happy cloud computing.